Hello and welcome to the next day in our 30-day Tesseract Dice campaign here on YouTube, where we're bringing you 30 days of back-to-back science videos every single day, talking about the science of our Tesseract dice. And today, we're going to be talking about black holes. Now, black holes, as far as we know so far, are just this really condensed mass of matter that is so heavy that it attracts everything else around it. In fact, its pull is so intense that once light passes a certain point that we call the event horizon, all of a sudden it stops appearing. It stops escaping from the pull of the black hole, so we can't tell what goes on or happens inside that little bunch of darkness. So if light can't escape, and that's one of the fastest things we possibly know of, can anything escape? Well, the answer is yes, we think, and it's called quantum tunneling. There aren't many things that are smaller than an atom, but there are these things called subatomic particles, like protons, or neutrons, or electrons, or quarks, the positive, neutral, and negative charges that make up an atom. And subatomic particles usually bounce around off each other, stick to each other, whatever their charges decide they should do inside the constraints of an atom. Atoms kind of take up a set amount of space for the most part, and it's a very, very small amount of space. But some subatomic particles, like quarks, are actually known to have the ability to move faster than the speed of light. Subatomic particles in general have very unpredictable movement natures. They move in very erratic and unpredictable patterns. So scientists have noticed this ability called quantum tunneling, where theoretically an electron bouncing on one valley on the side of a mountain could suddenly tunnel through all the matter in the entire mountain and just suddenly appear on the other side of the mountain. This is called quantum tunneling. Theoretically, matter has the ability to move through other matter, and it happens fairly often for one particle out of billions and trillions. And technically any particle could do it, which means, mathematically speaking, there is the chance, very, very tiny chance, that you could suddenly, let's say, walk through a wall, that every single particle in your body would suddenly be able to quantum tunnel through a wall. Now, we know that this must happen at black holes because when we look at them, we notice this thing called Hawking radiation, which the physicist Stephen Hawking noticed, a slight glow around black holes, which means that tiny little photons and quarks and other subatomic particles are slowly escaping from the black hole's grasp, which means they're moving very, very fast or suddenly quantum tunnel out of a black hole. So yes, even though we're taught that quote-unquote nothing can escape a black hole, things can escape a black hole. It's just such a small amount of very, very small particles that we basically don't count it, but technically things can escape the grasp of a black hole. Thank you so much for watching today's episode of The Drawing Board and joining us for the next installment of our 30-day Tesseract Dice campaign, where we're talking about the science of our Tesseract dice. If you want to see more about the dice, you can check out the link in the description below, sending you to our Kickstarter page for those dice. And if you just want to follow along with the science of our 30-day Tesseract Dice campaign here on YouTube, you can click the subscribe button, which is in one of those corners there, little blue button, and you can subscribe and follow along with our day-to-day episodes, and make sure to join us tomorrow when we come back talking about the science of wormholes. See you guys then.